Okay, so we're going to start reviewing for our first test of the fourth quarter. Again, this review sheet with your own work is going to be due on Tuesday, and then the corrections for it, which again I will upload the answer key onto eBoard. That will be due the day of your test, which is Wednesday. Okay, so this first question. Mr. Sweet gives a history exam to 10 students in his class. The results are listed below. Determine the mean, median, sample, standard deviation, and interquartile range. So if you remember, this was the first day of probability when we were just listing things in the calculator. So if you press Stat, Edit, you're going to clear out anything that you already have, including list 1, list 2, and you're going to input all of this information. It does not have to be in order at all. And then once it's all in your list, you're going to press Stat and then Calc, 1 var stats, so number 1, and you're just going to keep pressing enter until it gives you all of your information. So remember, for this question though, you have to write down all of the information that it's giving you on your calculator. So we have X bar, Okay, so this is all the work that you're going to need, and then your answer, you're looking for the mean. So the mean in this case is X with a little line on top, so the mean is 78.2. Then you have the median is 80.5. The sample standard deviation, that's the one that has an X. That has an S, I'm sorry, is, what was that? 10.6541593. The interquartile range. So here you actually have to do a little bit of work. So you take your Q3 and Q1 and you subtract them. So you would do 85 minus 70 is equal to 15. Second question, a lineup for tickets to a local concert is normally distributed. Had a mean waiting time of 20 minutes, standard deviation of 4. Draw a normal curve to represent this spread of data. So let's start by doing that. So my normal curve is going to look, I'm going to make it as big as possible. And then the mean is 20 and the standard deviation is 4. So the mean is 20. And then you have standard deviation of 4. That's 1 standard deviation, 2 standard deviations, and 3 standard deviations. So it'd be 1. But again, we also have to remember that we go by halves for our curves. So this is going to be 18. In the middle here would be 14. Middle here would be 10. This is 22. This is 26, and this is 30. All right, so then we could put the percentages in also. So in my percentages, I'm going to have, zoom in as much as possible. So half a standard deviation, this is 19.1, 19.1, 15, 15. Then we have 9.2, and 9.2, 4.4, 4.4, 1.7, and 0.5, and 0.5. And then this here is less than 0.1 and less than 0.1, just to fill in the chart. All right, so the second question says, using this normal curve, determine what percentages between 14 and 22 minutes. So 14 is right here, and 22 is right here. So I would take 9.2 plus 15 plus 19.1 plus 19.1, and I end up getting 62.4% of the data. And then number 3. So the shelf life of a particular dairy product is normally distributed with a mean of 12 days and standard deviation of 3 days. So draw a normal curve. So normal curve first. You want to make this as big as possible so you have enough room. So the mean is 12, and then it has a standard deviation of 3. So it would be 9, 6, 3, 15, 18, and 21. And then again, we have our halves in there. So this is our, let's undo that. And then again, we have our halves in there. So this is going to be 13.5, 16.5, and 19.5. Then to go backwards, it's going to be 10.5, 7.5, and 4.5. So then we just have our percentages, which is the same thing that we just put in on that last one. So half is 19.1. Then we have 15, 15, and then we have 9.2, 4.4, 1.7, 0.5, less than 0.1. And it's the same thing on both sides. Less than 0.1. All right, so questions that are involving this. Using this normal curve, determine the time interval for 60% of the data set spread. So 68%, that's part of our empirical rule, so that would be 1 standard deviation away. So this would be, the time interval would be from 68%. This is from 9 to 15 days. Okay, that's 1 standard deviation is 68%. And then we also have 95%. So for 95%, that's a second empirical rule for 2 standard deviations away. So now I'm looking from here until here. So this would be 6 to 18 days. And then the last one would be 99.7%. That's 3 standard deviations away, so that's the last interval that I had put. So this is 3 to 21 days. Okay, next we have 2 people are drawing chocolate from a 50-piece size candy bag. Catherine pulled out 13 pieces of milk. Rebecca drew 8 pieces of milk. Find the margins of error for each girl picking out milk chocolate candies. So here I need to find 2 things because I'm looking for 2 of them. So for Catherine, she had taken out 13 out of 50. That's her sample proportion. So 13 divided by 50 gives me 0.26. And this is P for Catherine. So if you remember, margin of error, it's 2 times the square root of P times 1 minus P divided by N. N, because you have 50 pieces of candy, N is 50. So in your calculator, you would do 2 times the square root, and you can use that alpha y equals button to make a nice fraction. That way you don't have to worry about parentheses. Divided by 50. And this margin of error is equal to 0.1240644. 994. Okay, so, and then we have Rebecca. Rebecca had taken out 8 pieces of candy divided by 50 total. So 8 divided by 50 gives me 0.16, which is her p-value. So to do her margin of error, we have the same thing because we have 50 still as the sample size, but her proportion now is 0.16. This is the square root of 0.16 times 1 minus 0.16 divided by 50. And I get 0.10369185112. Number 5 says that in an ecological study, the sampling mean proportion is 0.28 and the sample size is 50. What is the margin of error with a confidence level of 95%? So to find the MO, or the margin of error, so here we have the p-value, the sampling mean proportion is 0.28, and the sample size is 50. So this is going to be 2 times the square root of 0.28 times 1 minus 0.28 divided by the 50. And I get that this is equal to 0.12699,60629. So write a 95% confidence interval that includes plausible values for the true proportion. So if you remember, your 95% confidence interval is the mean, and then you add and subtract 2 standard deviations. This 2 standard deviations is equal to the margin of error. So you're going to take the mean proportion is 0.28, and you're going to add and subtract this 0.12699,60629 number. All right, so I'm going to do 0.28 plus that number and 0.28 minus that number. So my confidence interval here is going to be, my final answer is 0.1530039,371 up until 0.406,996,0629. And that would be my interval. So this interval here contains 95% of my data. This is kind of like what we were doing for the second question in number 3. 95% represents 2 standard deviations away. And again, 2 standard deviations also represents the margin of error. So with number 6, this one is kind of like the one that we had talked about with the drive-through. So for number 6, she is waiting for her little sister. So she's waiting 12 minutes and she wants to know if that's usual or not. So what you have to do here is figure out if this 12 minutes, if for it to be unusual, it has to be outside of a 95% confidence interval, meaning that it has to be outside of 95% of the data, because if something is usual, it's within 95%. If it's unusual, then it's on the outside. So when she went back to take this data, she found that the mean wait time was 6 minutes and the standard deviation was 2 minutes. So you take the mean, you add and subtract 2 standard deviations. So add and subtract 2 times 2. So this ends up giving you 6 minus 4 from 2 minutes to 10 minutes. Anywhere between 2 minutes and 10 minutes is usual for her to pick up for how long she's waiting outside for her sister. So because this 12 minutes that day is not within this 95% confidence interval, was it unusual? The answer to this would be yes. For number 7, the monthly utility bills in a city have a mean of 70 and standard deviation of 8. Find how many standard deviations away the utility bills of 60, 71, and 92 are. So how many standard deviations away? This is talking about the z-scores. So the z-scores, if you remember, it's the value minus the mean divided by the standard deviation. So for 60, you would do 60 minus the mean is 70 divided by the standard deviation of 8. So this ends up giving me, for 60, is negative 1.25. For 71, 71 minus 70 divided by 8, 0.125 standard deviations away from the mean. So that one's nice and close. 92 then, 92 minus the mean, minus divided by 8, gives me 2.75 standard deviations away. All right, so if it was asking about anywhere that would be usual, $60 would be usual, $71 would be usual, but 92 would be unusual because 92 falls outside of 2 standard deviations away. And then for number 8, the car tire has a mean lifespan of 35,000 with a standard deviation of 2250. If the lifespan of 2 randomly selected would be 34,000 and 37,000, determine what percentage of tires falls within these lifespans. So this, first you have to find the z-scores, and then you have to use your calculator to find the percentage. So first you would do 34,000, find the z-score for 34,000. So that'd be 34,000 minus 35,000 divided by the standard deviation. And this gives me negative 0.4 repeating. For 37,000 minus 35,000 divided by 2250 gives me 0.8 repeating. So in your calculator, you would do second, bars, number 2. Your lower boundary, this is the lower, this is the upper. Your lower boundary is negative 0.4 repeating. The upper boundary is 0.8 repeating. And it wants the percentage, so you have to write 48.46054231%. Okay, number 9. In a study of 96 varsity golf players, it was found that the ages of these players were normally distributed with a mean age of 16, standard deviation of 2. Were there 9 golf players in this study under the age of 13? So I need to know, where is 13 on my bell curve? So I need to figure out the z-score. So for 13, the z-score for 13, I would do 13 minus the mean of 16 divided by the standard deviation is 2. So 13 minus 16 divided by 2 gives me negative 1.5. Okay, the key word here is under the age of 13. So this then has to be my upper boundary. And my lower boundary is where I'm going to type in a whole bunch of negative 9s. So I have to figure out what percentage this is. So second, vars, number 2. So my lower boundary, because I can be as young as possible, so I keep going down. And my upper boundary is negative 1.5. And then I just keep pressing enter until it gives me 6.68% about. Okay? That's not what the question's asking me, though. This is saying, were there 9 golf players that were under the age of 13? So this is really 6.68% of the 96 total players. So I have that number in my calculator. I can just do times 96. And this gives me that there were 6.4. This is a decimal down here. 6.4 golf players that were less than 13 years old. So the answer is no. No, there were not 9, there were only 6.4, so really only like 6. Okay, so this next question, number 10, talks about our regression equation. So write the exponential regression equation for this data set. So he invested he invested $380 in stocks over the next 5 years. The investment grew as shown in the table. So here I have to plug everything into my calculator. So remember, your diagnostics have to be on for this. So if you have to go through your catalog to turn it on, do that now. So we have stat, edit. I'm going to fill in 2 lists here for my 2 data sets. So once I have that all typed in my calculator, I'm going to press stat, move over to calc, and I'm going to look for the exponential regression equation. So that is going to be 0. You can press enter once you're hovering it, and then just click enter until it gives you the pieces of information that you need. Again, you have to write everything out that you see on your screen. So you have y equals this. So this is the work that you need. Okay, you didn't actually answer any questions yet. You have to plug everything in. So this says rounding all values to the nearest hundredth. So my answer, I'll put my answer in blue. My answer is going to be y equals 379.92 times 1.04 raised to the power of x. So this means that this is how much you're starting with. So you're starting with 379.92, which is really close to this 380. Again, you're not going to get anything exact. It's going to be dependent upon how close your correlation coefficient is to 1. And then this piece of information here tells me that we are increasing by 4%. Okay. So the second part, though, using this equation, find the value of her stock to the nearest dollar 10 years after her initial purchase. So 10 years after her initial purchase, that's going to be your X value, because X is the year since the investment, and you're looking for Y. You're looking for the value of the stock. So you're going to have Y equals 379.92 times 1.04 raised to the power of 10. And you get that is going to be equal to $562.37. Okay, so this is the answer to the first part. This is the answer to the second part. Okay, number 11, same type of thing. It wants an exponential regression equation. So that shows the amount of water vapors as Y, and then the air temperature is X. So take a minute now and plug all this data into your calculator. Your work is going to be everything you see on your calculator screen. Okay, so this wants rounding all values to the nearest thousandth. So my answer in red is Y equals 4.194 times 1.068 raised to the power of x. So that answers the first part. The second part, using this equation, predict the air temperature. So predict x, or solve for x, when the amount of water vapor that will saturate 1 cubic meter of air is 65 grams. So when y is 65, what is x? Is basically what this is saying. So when y is 65, what is x? So first we divide by 4.194. And I get 15.49833 is equal to 1.068 raised to the power of x. These canceled. So now I have log of 15.49833 is equal to x log 1.068. I divide both sides by the log of 1.068. And this one's rounded to the nearest tenth of a degree. So I get x equals 41.7. Okay, number 12, same thing. It just wants, though, the equation. So this is only one question in here. The breaking strength in Y in tons of steel cable with diameter D in inches is given to the table below. So this is actually going to be, you're not going to have an X value. You're going to have a D value. Okay, so we're going to have Y equals A times B raised to the power of X. This is an exponential regression equation, so you put everything into your calculator. A equals 4.75 Okay, so the equation rounded to the nearest tenth, it would be y equals 4.8 times 6.8. All right, 13. So we're going to talk about probability now. So for 13, this is talking about theoretical probability. This is based on what you think would happen. This is not based on any experiment. So, for example, Melissa rolls a die that it will land on an even number. So, on a die is 1 through 6. So you have 2, 4, or 6 out of 6 possibilities. So the probability you would expect it would be 1/2. So the probability, again, this is theoretical probability, of an even would be 1/2. Okay, the second one. So I changed this on your paper to rolls a die 1,500 times, and her results are shown below. So this is an experiment. So this is either, you can call it empirical probability or experimental probability. I told you in class that it means the same thing. That the die will landed on an even number. So even was here, here, and here. So the probability here for even, 245 plus 280 plus 230 is 755 out of 1,500 total times, or 151 out of 300, or you could say 50.3 repeating percent. All right, 15 out of high school, some students play soccer and some do not. Some do now. Some do not. Also, some play basketball and some do not. Suppose that 230 play soccer, 190 play basketball, and 60 play both. total of 500. So this wants a Venn diagram to represent this data. So my Venn diagram has a rectangle that includes for everybody, and then I'm going to have this circle and this circle. So this here is going to be basketball, this is going to be soccer, and this in the middle is going to be both. So 230 play soccer, 190 play basketball, and 60 play both. So I told you in class, always start out by doing the middle first. So 60 play both. So this whole circle here for basketball has to add together to give me 190. So that means that in here, I have 130 people. Right, 130 plus 60 gives me 190. And then in here, my soccer circle has to add to be 230. So I would do 230 minus 60. And this gives me 170. So out of all of those people, 130 plus 170 plus 60, that accounts for 360 people, but there's a total of 500. So somewhere outside in a corner of my rectangle, I have to include those missing people. So I would do 500 minus 360 to give me 140 people that don't like to play either basketball or soccer. So determine how many students do not play either. 140 is the answer. Okay, for number 16, if 40 people were surveyed in the Venn diagram shown to the right, how many people did each of those things? So the problem that I have with this one, with this Venn diagram, is that it just doesn't have a number in the corner to tell me if anybody is missing. So let's just make sure. So if we add all those numbers together, they should add to be 40 if everyone was included. 713, 9, 5, 2, and 2. So that only has 29. So we're actually missing 11 people. So just in case, we're going to put it at 11 in the quarter. So for letter A, how many people owned a Wii? So this is your people that owned a Wii. So you have to add all those numbers together. So you have 9, 5, 4. So this is 18. And then the second thing, the third question says owned at least 2 consoles. So these people own 2, these people own 2, these people own 2, and these people own 3. So you would add all 4 of those numbers together. So that would give you 17. That would give you 17. Letter D, owned an Xbox or a Wii. So everybody that owns an Xbox is in here. Everybody that owns a Wii is in here. You add all of those numbers together, and you have 26. And now we have owned an Xbox and a Wii, but not a PS3. So Xbox and Wii, that would be here. And a Wii would be here, but because we're not also owning a PS3, we do not include that. So this would just be 9. Okay, 17. Of the 650 juniors in Arlington High School, 648 are enrolled in A2, 292 are enrolled in physics, and 180 are enrolled in both at the same time. If one of the 650 juniors was picked at random, what is the probability that they are taking physics if we know that they are in Algebra 2? So this is looking for the probability that they're taking physics given that they're taking Algebra 2. So this is a conditional. So this is the probability of both physics and Algebra 2 divided by the probability of the given. So the probability of Algebra 2. Okay, so we need those pieces of information. So here, the probability of both. So this says 180 are taking both courses at the same time. And then the probability of the given is algebra 2. So we would do here, again, remember, it's the probability of it. It's not just how many. So the probability that they are taking both is 180 out of 650. Remember, probability cannot be more than 1. And then the probability that they're in algebra 2 would be 468 people out of the 650. So you can do that right in your calculator. You can use your alpha y equals button. So 180 out of 650. And then you would have divided by alpha f1, 468 out of 650. So this gives you 5 out of 13, or you could say 38.46%. So, or about 38.5%. Number 18, historically, a given day at the beginning of March in upstate New York has 18% chance of snow and 12% chance of rain. If there's a 4% chance it will rain and snow, there's two questions here. First, we have to find the probability that it will rain given that it's snowing. That it will rain given that it is snowing. So this is the probability of rain and snow divided by the probability that it will just snow. So rain and snow is 4% or 0.04 divided by the probability that it will snow is 0.18. So 0.04 divided by 0.18 gives me about 22.2%. About. Okay, second question. The probability that it will snow given that it is raining. So again, this is the probability of both divided by the probability that it is raining. So this is 0.04 still, divided by that it will rain is 0.12. So 0.04 divided by 0.12 gives me 33, about 0.3%. Okay, 19. I like this question a lot because this one you have to think a little bit for it. A suburban high school has a population of 1,598 students. The number of students who participate in drama is 892. So the probability that they are in drama is 892 out of 1,598. The probability for honor society is 540 out of 1,598. And then the probability that they participate in either or, so D union H, is 1062 out of 1,598. What is the probability that a student participates in both? So we're looking for the probability of both, the probability of D intersect H. So if you look at your list of formulas that you should be memorizing, there's 3 of them. There's only one that I can use this information that's given to me in order to figure out what this is. And that's going to be the formula that's under the union side. So that's the formula that says the probability of the union is equal to the probability of each individual one added together, subtract by the probability of the one that is together, both of them. So we would do 1062 over 1598 is equal to 892 divided by 1598 plus 540 divided by 1598, and then minus, this is what I'm looking for. Okay, so I can add these two together if I want here. and then subtract, or I can just subtract each one. So 892. You should end up getting that the probability of them doing both is equal to 370 out of 1598. So 370 are in both Drama Club and Honor Society. Okay, so that wraps up all of the new information that we're doing. So some old stuff that I think you should remember for your exam is going to be the first one being a system of equations. So if you remember this is a circle and this is a line. To do this, you need to do some substitution. So you're going to plug this in for y. It's already solved for y already, so you can just substitute it back into the circle. So you can do x minus 2 squared plus x minus 8 plus 1 squared is equal to 25. You cannot take, this is plus 1. You cannot just take the square root of everything. Stop doing that. Okay, you have to actually expand this. So this is going to be x minus 2 times x minus 2 plus x minus 7 times x minus 7 is equal to 25. So this gives me x squared minus 4x plus 4 plus x squared minus 14x plus 49 is equal to 25. So on this side I have 2x squared minus 18x plus 53 is equal to 25. I subtract 25 and I get 2x squared minus 18x plus 28 is equal to 0. Okay? So one thing I can do right away is take out 2's from everything to make it easier. So this is x squared minus 9x plus 14 equals 0. So this is x. If you do master product on this, you should end up getting x minus 7 times x minus 2 equals 0. So I'm going to bring this over here. You get x equals 7 and x equals 2. But you have to get the y value still. So you have y equals x minus 8. So y equals 7 minus 8 is negative 1. So this point is 7 comma negative 1. You have to write it in parentheses. This one here, y equals x minus 8. Y equals 2 minus 8 gives me y equals negative 6. So this point here is 2 comma negative 6 in parentheses. And then if you want to put it in the solution set, you can. But that is your answer. This did not ask me to justify, so I don't have to plug anything back in. But if it did ask me to justify, I would have to have 4 different checks. I have 2 points and 2 equations. I have to check everything all out. Okay? And then the last one is long division. So this, if you look right away here, bell should be going off that you need a placeholder. So this is x plus 3 divided by 2x to the third plus 4x squared plus 0x minus 5. So x goes into 2x to the third, 2x squared times. So I multiply 2x squared times what's out front here. So this gives me 2x to the third plus 6x squared. Put it in parentheses and subtract. These cancel. 4 minus 6 gives me negative 2x squared. Bring down your plus 0x. X goes into negative 2x squared, negative 2x times. So we multiply this negative 2x times everything in my parentheses. So this gives me negative 2x squared minus 6x. Put it in parentheses and subtract it. Negative 2x squared minus negative 2x squared cancels. 0 minus negative 6 becomes positive 6x. Bring down your minus 5. X goes into 6x 6 times. Multiply 6 times everything in my parentheses over here. So this gives me 6x plus 18. Put it in parentheses, subtract it. 6 minus 6 cancels. Negative 5 minus 18 gives me negative 23. So this is negative 23 over x plus 3. So perform the indicated operation. Your answer, you would get 2x squared minus 2x plus 6 minus 23 over x plus 3. So this doesn't ask me anything about whether it's a factor or anything. It just wanted me to do long division. So that would be your answer. Okay, that is it. Happy studying.